All right. So next we go to, okay, next we go to graded potential. Okay, what is graded potential? Okay, remember, graded potential is produced when there is weak stimulus. Remember, to produce action potential, if you want to have impulse, right, you want to have the peak, macam tu, right, you need to have a very strong stimulus. And the stimulus must be able to reach the threshold. I did mention earlier, kan? The stimulus must be able to reach the threshold. But what if the stimulus is very weak? So weak stimulus produce a slight change of membrane potential, a very slight change of the distributions of ion, what we call as membrane potential. So this is what we call as the graded potential. Okay, graded potential can be either hyperpolarization or depolarization. Okay, what does it mean by hyperpolarization? Hyperpolarization means the membrane potential become more negative. Become more negative. Okay, from negative 70, resting is negative 70. Look at this picture. Let's say resting membrane potential is negative 70 millivolts. Okay, but hyperpolarization will produce the membrane potential that is more negative. Cuba tengok sini. Nampak tak? Dia jadi lebih negatif, like negative 50, 75 or negative 80 millivolts. The value is more negative. So this is what we call as hyperpolarization. Okay, so as you can see here, the hyperpolarization makes the membrane potential is further away. Further away from the threshold. So is it easier or is it more difficult to produce an action potential? It will become more difficult to produce action potential because it is further away from the threshold. Okay, right, that is hyperpolarization. What happened during this time? What makes the membrane become more negative? That is due to the opening of potassium ion channel. Potassium ion channel, right? You can see here, right? When more, okay, remember we have discussed earlier, right? This is membrane, inside of the membrane. This is inside, this is outside. Remember, inside of the membrane, we have concentration of potassium ion that is very high and low concentration of potassium ion outside. All right? Remember, membrane has so many potassium ion channel. All right? So what happened? Many potassium ion channel that is open, so more potassium ion leaving the cell, diffuse out. You just imagine there are more and more and more potassium ion leaving the cell or leaving the neuron from the outside of the cytosol to the outside, to the extracellular fluid. That makes inside of the membrane will become more and more and more negative. Okay, right? So that is the reason that makes hyperpolarization happen. Okay, that is due to the stimulus, the weak stimulus cause the opening of potassium ion channel. Okay, right. Madam, I couldn't connect this information, the graded potential, hyperpolarization to our daily life. So, kat mana kita apply? When we are applying this kind of hyperpolarization or graded potential? Kan? Okay. Now, have you ever eat or consume okay, as simple as Panadol or pain reducing tablet? Okay, ubat tahan sakit kita makan. So bila kita makan ubat tahan sakit, we are not feeling the pain, right? What makes we are not feeling the pain? That is because the impulse has been blocked, right? The impulse that is transmitted to your pain area, right, to your pain receptor has been blocked due to due to the opening of potassium ion channel, right? So potassium ion diffused out of the membrane. So the membrane become more negative, right? So action potential cannot be generated and transmitted. So when action potential cannot be transmitted, so the impulse cannot be sent from one neuron to another neuron to another neuron and going to your pain receptor, for example, right? So the impulse is blocked. That is why you are not going to feel the pain because it is blocked by the medication. So the medication caused the opening of potassium ion channel, which block the transmission of impulse. Okay, so that is the application. But that is way too deep lah for me to explain more. But that is the concept. Yeah, right. But when you feel the pain, you can have the pain. That is because the what you call it? Somehow the medication has stopped, all right? And then the what you call it? The ion channel is no longer blocked. So action potential can be generated, and that is why the impulse is sent from one neuron to another neuron and going to your pain receptor. Then you are going to feel the pain. Okay, so that is how it works, right? Okay, so next one. Graded potential can be either hyperpolarization or depolarization. Okay, so what does it mean by depolarization? Depolarization is when the stimulus open the sodium ion channel. So when we are talking about depolarization, meaning you have to know that sodium ion channel is open. All right, so now tell me, what happened when sodium ion channel is open? Yes, sodium ion move into the cell. Remember why sodium ion move into the cell? Because concentration of sodium ion is higher outside and lower inside. So it is going to follow the concentration gradient, right? So sodium ion will diffuse inside. You can see what happened to the membrane potential. The membrane potential become less negative. Since we are adding positive charge sodium ion into the cell. So the membrane will become less negative. You can see it is not really far from the threshold. So this is what we call as depolarization. Since it is a very weak stimulus, so depolarization do happen, but the strength of stimulus is not strong enough to reach or to depolarize the membrane in reaching the threshold. Okay, stimulus tu ada tapi tak kuat. Tak kuat yang tak sampai threshold. So still you are not going to produce action potential, right? But the membrane potential do change, right? Become less negative. But if let's say the stimulus is very strong enough and able to reach the threshold, then you are going to have the action potential. Alright? Okay, so this is what we call as apa nama tu? Depolarization. Graded potential due to depolarization. So ingatlah, this is the shape of graded potential due to hyperpolarization, right? Movement of potassium ion out of the cell, and this is depolarization. Graded potential depolarization, right? Due to the opening of sodium ion channel and movement of sodium ion into the cell. Okay, right. So this, remember, this is happen when the stimulus is weak. All right. All right. It is not able to produce action potential because the membrane potential is not able to reach the threshold. Okay, and thus it resulted with graded potential. Okay. Right. Okay. So look at here, the summary process of hyperpolarization. The stimulus, we are referring here the weak stimulus, right? Since the stimulus is weak, so the stimulus caused the opening of potassium ion channel. So potassium ion diffuse out of the axon, right? Diffuse out of the axon. Why it is diffused out of the axon? We have discussed because concentration of potassium ion is higher inside, right? And lower outside. on the outside. So that is why potassium ion diffuse out of the membrane. So what happened to the membrane potential? So the membrane potential or inside of the membrane become more negative. Okay, the value will become more negative and thus it is more difficult to transmit impulse, right? Because it is far away from the threshold. So this is what we call as inhibitory effect. You are inhibiting impulse transmission. Okay, so this is what we call as inhibitory effect. All right. Okay, as for depolarization, as the process of depolarization, okay, look at depolarization. Okay, right. In the process of depolarization, okay, the weak stimulus, right, induce the opening of sodium ion channel, right, ataupun kalau lagi best, voltage gated sodium ion channel to open, and what happens, sodium ion diffuse into the axon. Why axon? Because we know that concentration of sodium ion is higher outside and low inside compared to inside of the axon. So that is why sodium ion diffuse into the axon and cause the membrane potential or inside of the membrane to become less negative. But it is closer to transmit the impulse. Okay, it is less negative, but closer to the what you call it? Closer to the siapa namanya tu? Threshold. Okay, so this is what we call as excitatory effect, meaning that a condition that is close to exciting the action potential to produce the action potential. Okay, if there is sufficient strong stimulus, the depolarization can reach the threshold and action potential can be produced. Okay, so syarat enough stimulus where cause the depolarization to, right, then you are going to have the action potential. Okay, let's continue. All right. Next part is in the generation of action potential. Okay, remember to generate action potential, this one. Okay, to generate an action potential, it must be strong enough stimulus. What does it mean by strong enough stimulus? It must cause depolarization. Remember what is depolarization means? What is depolarization means? Yes, okay. It is related to the influx. Oh, I forgot to mention you another word. Despite diffuse in, you can use the word influx. Okay, influx of sodium ion into the axon or into the cell. All right, so it must be strong enough stimulus that produce or that cause depolarization or influx or diffusion of sodium ion into the axon or into the cell and able to reach the threshold. So meaning that the influx or the diffusion of sodium ion into the cell cause the membrane potential to become less negative, less negative, less negative, less negative, and able to reach the threshold. Okay, so you can see here, this one showing you that depolarization, right, happen and reaching the threshold. So as it reached the threshold, then you are going to have the ZAS, the action potential. Right, so the range of threshold is around negative 50 to negative 60 millivolts. So you can see here negative 50 millivolts. Resting membrane potential is way negative lah, maybe around negative 70 millivolts. Okay. All right. So what happened during generation of action potential is the membrane potential increase. Membrane potential increase around 15 to 20 millivolts more positive than the resting membrane potential. So you can see that the membrane potential increase and become positive around 15 to 20 millivolts more positive. Okay, more positive than the resting membrane potential. So transmission of neural impulse or action potential can occur. All right. So that is how impulse is generated. It must be due to depolarization, and the depolarization able to reach the threshold value. Then you will have the action potential. Okay. Right. Now let's look at the step-by-step process of generation of action. Okay, so the first one is the resting state. So where is the resting state? So here is the resting state. Remember, resting state is the resting membrane potential. So at this point, the membrane is thus not producing any impulse, right? All ion channel are closed, all right? Apa nama tu? Cakap tadi, lupa dah. Okay. So next stage is depolarization, right? So depolarization here, you can see some or few sodium ion channels start to open, right? Few sodium ion channels start to open and depolarization happen. Membrane potential become less negative, right? And able to reach the threshold. So once it reached the threshold, then we are going to have the rising phase. So this is the rising phase. Okay, the rising phase. All right, so what happened during the rising phase? So you can see many or more voltage gated sodium ion channel is open. Thus, you have more influx of sodium ion, which makes the membrane potential become positive. All right, okay. Next we have is the falling phase. So falling phase is here. This is what we call as the falling phase. Okay, the what we call it as repolarization. Okay, what happened here? Tolong salin right? During falling phase, the sodium ion channel is closed. No more influx of sodium ion. Okay, sodium ion channel is closed, but what you have is potassium ion channel is open. Right? So you have efflux. Efflux means diffuse out. Efflux of potassium ion. Potassium ion diffuse out of the cell, which makes the membrane potential become dropping. Dropping, 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 and dropping, and until reaching to this area, which we call as undershoot. Okay, stage number 5 is undershoot. All right, so this is undershoot. Okay, so you can see that the sodium ion channel still closed, but potassium ion channel still open, which makes potassium ion diffuse out of the membrane and make it more negative. Negative than resting. You can see the value is more negative than the resting. All right, okay. And next one is undershoot. There is a period which we call as refractory period. So here is refractory period. So between the repolarization and the before the undershoot, this is what we call as refractory period. Okay, what happened during this refractory period? This is the time during which another stimulus, even another stimulus is given to the neuron. No matter how strong is the stimulus, it will not lead to a second action potential. So meaning that during the refractory period, if you give stimulus, even though the stimulus is very strong enough, ataupun very, very strong, it will not produce action potential. Tak akan terhasil pun another action potential, another peak like that. Macam gambar medium lukis kejap they are not going to produce any peak of action in this refractory. Can anyone answer me why there is not going to have any action potential produced in this refractory period, even so the stimulus is very strong? Remember, during repolarization, during this period, Okay, during this period, all sodium ion channel is closed. All sodium ion channel is closed. So when all sodium ion channel is closed, so how depolarization is able to happen? How sodium ion is going to diffuse or influx into the axon since the sodium ion is closed. That is why even so there is a very strong stimulus, right? So you are not going, there is no way that second action potential can be produced during that refractory period, because during that time all sodium ion channel are closed. No influx of sodium, because the requirement for action potential is depolarization. But now there is no way for depolarization to happen. Faham right? So that is why during refractory period, there is no way second action potential will be produced, even the stimulus is very strong. Okay, right? So this is the answer. Okay, because all of the sodium ion channel are closed or inactivated. All right, okay. So this is due to all sodium ion channel are inactivated, all right, or inactivation loop blocks sodium ion channel to flow through the channel. Okay. Okay. So, all right, this is a little bit explanation about the undershoot. So remember which one is the undershoot? The undershoot is here, right? The undershoot is here. Okay, so this is the undershoot. So let's see what happened actually during the undershoot. Okay, during the undershoot, the membrane temporarily become more negative than the resting membrane potential. So the value of membrane potential is more negative. All right, it occurs before the membrane returns back to its resting membrane potential. Right, you can see back to the picture. It happened, the undershoot happened before the resting membrane potential is re-established. Nampak tak kat situ? Right, so the undershoot is the very lowest point before the membrane back to the resting membrane potential. Okay, right. So at the lowest level of the undershoot, all of the potassium ion channel will be completely closed. At the lowest level of the undershoot, okay, all potassium ion channel will be closed, and during the undershoot, it can generate second action potential if there is strong enough stimulus. So meaning that, here, from here, let me use another color. Okay, so from here to here. Okay, so you can see from here to here, from the two black lines, right? So that is the undershoot area. So during that point, if you have a very strong stimulus, you might have second action potential, but not during the refractory period. Right. Oh yeah, one more thing. Right. In exam, there is one question that quite famous. Okay. Right. Which the question asking you this part. Okay. The question asking you X. X here is referring to the re-establishment of resting membrane potential. Soalan akan tanya, the question will ask you, how X ataupun how resting membrane potential is re-established here. Resting membrane potential is re-established. Okay, meaning that from the undershoot, what makes the undershoot then return back to resting membrane potential? Jawapan dia ialah the action of sodium potassium pump. Remember, sodium potassium pump will balance the ion, right? Okay, so the answer is here. So please take note. The action of sodium potassium pump. Okay, right? Okay, next, moving on. All right, so this is the detailed explanation. You have this picture in textbook. So go and check your textbook. Right. So let's start with the first stage. The first stage here is showing you resting. All right. So look what happened during resting membrane potential. During resting membrane potential, the sodium ion and the potassium ion channel are closed. All right, closed, and then you can see inside of the membrane is more negative compared to the outside resting. Okay, now let's go and look at the depolarization stage, stage number 2. Okay, in stage number 2, a stimulus, right? A stimulus is given to the neuron, which makes it open some of the sodium ion channel. So some of the sodium ion channel is open. Okay, so assuming this one, the yellow one is the sodium ion channel, and the orange one is the potassium ion channel. Right? So a stimulus is given and it opens some of the sodium ion channel. So sodium ion inflow. Okay, another word. Despite influx, you can also use the word inflow. Okay, or diffuse in. Sodium ion inflow through the channel and depolarize the membrane. So if the depolarization reach the threshold, then it will trigger the action potential. Okay, so stage number 3. Next is stage number 3. Depolarization keep continuing, right? The rising phase. Now we are referring to the rising phase, stage number 3. Okay, depolarization open most of sodium ion channel. So you can see just now it only opened one ion channel, sodium ion channel, but now you have more opening of sodium ion channel in the rising phase. Okay, so depolarization open most sodium ion channel, while potassium ion channel still remain closed. So sodium ion influx and mix inside the membrane become positive compared to the outside. All right. And during the falling phase, stage number 4, you can see during the falling phase, most of the sodium ion channel become inactivated. So you can see the sodium ion channel is now inactivated. It is closed, but most of potassium ion channel is open. And that is why potassium ion is diffused out, or we call it as outflow or efflux. Efflux out of the cell and makes the inside of the membrane negative again. All right. This process will continue until undershoot. You can see in undershoot stage number 5 here, right? The sodium ion channel still closed. This one, sodium ion channel still closed, but some of the potassium ion channel still open. So meaning that there is still outflow of potassium ion, right? But as it reached to the very lowest point of the undershoot, right? So lowest point of the undershoot, so all of the potassium ion channel will be closed. All right. And later you can see the membrane is written back to the resting membrane potential. So the resting membrane potential after the undershoot, right, is established by the action of sodium, potassium, okay, right? So these are the detailed explanations. So in exam, you might be asked what happened to the ion channel in stage 3, stage 4, for example, right? Where can you produce second action potential? Which area that you cannot produce second action potential and whatnot? Okay, so you have to know what happened to the ion channel with respect to the each phase. Okay. Now you know how the impulse is generated. You know how the action potential is generated. It must be due to depolarization, right? The opening of sodium ion channel influx, right? Inflow and makes the membrane become less negative, able to reach the threshold and produce the action potential. Okay, next question is how the impulse is moving along the neuron. Okay, so our next potential, okay, conduction of or transmission of action potential. Okay, our LO is to explain and compare the mechanism of impulse transmission along the axon that is myelinated and unmyelinated. All right, so myelinated axon is referring to the myelinated neuron lah. Okay, you have here the dendrites, the cell body, and this is myelin sheath. All right, but for unmyelinated, meaning the neuron is do not having the myelin sheath. Okay, so the transmission of impulse along the myelinated neuron and unmyelinated neuron is different. Okay, so we are going to learn that. Okay, so conduction along unmyelinated axon is known as continuous conduction. Okay, conduction of impulse along unmyelinated axon or unmyelinated neuron is called as continuous conduction, whereby conduction of impulse along a myelinated neuron or myelinated axon is known as cell tertiary conduction. So you might be asked essay question for this kind of subtopic, right? So let's say they kata the question asking you describe cell tertiary conduction. So you have to know that cell tertiary conduction is referring to the transmission of impulse along myelinated axon, right? And continuous conduction is transmission of impulse along unmyelinated axon. Okay. All right, so let's start with conduction of impulse along unmyelinated axon, which is known as continuous conduction. Okay, right. So what happened is action potential in one region, can depolarize the next region to reach the threshold, and thus the next region will produce action potential. Okay. Right, so imagine here, look at this picture, the right side. Impulse is moving from the dendrite to the axon. So that is the direction of impulse from the dendrite towards the axon terminal. Okay, so in other words, impulse is transfer in one direction only. From the dendrites to the axon, towards the axon, right? So when one region of the axon, like here, you can see this region is undergoing action potential. Picture number 1. Look what happened inside of the membrane. Inside of the membrane become positive. You can see here, inside of the membrane become positive. So, right, what happened is, an action potential is generated as sodium ion inflows into the or across the membrane, and the depolarization can spread, or the depolarization can cause the next region to also depolarize and reach the threshold. So maknanya apa? When one region undergo depolarization, it can cause the next region also to depolarize and reach the threshold, so that the next region also will be producing action potential. Okay, alright. So you just imagine dia macam spread macam tu. Okay, right. So producing new action potential in a forward direction. So when action potential is complete, the membrane will repolarize, and sodium ion will flow outward. Sodium ion will flow out of the cell. Okay, what does it mean? Okay, look at here. When the next region, this is the first region, this is the second region. When the first region is undergoing action potential, producing action potential, so it will cause the next region, which is the second region, to also depolarize and reach the threshold to produce action potential. So what happened to the previous region? Region 1. What happened to region 1? You can see region 1 is undergoing repolarization. Nampak tak sini? Inside of the cell become negative. All right. Okay. So the depolarization of action potential spread to the neighboring region of the membrane, reinitiating action potential there. The left of the region, meaning that referring to the first region of the membrane, will be depolarizing as potassium ion diffuse out of the cell. All right. And the process will continue. Depolarization and repolarization process will be repeated to the next region of the axon. So you can see now this is second region, this is the third region, this is the first region. The first region is now resting, right? The second region is now, you can see the third region is depolarizing. The second region is repolarizing. Nampak tak? So it happened like depolarization, spread, depolarization, then the previous region will be repolarized. Depolarize, repolarize, depolarize, repolarize. That is why the impulse is moving in one direction only. Alright, so the depolarization, repolarization process repeated in the next region of the membrane. And you can see local current of ion across the membrane cause the action potential to be propagated along the axon. Alright, okay, so to ease your understanding and imagination, action potential is then regenerated along the axon, and or we call it as wave of depolarization. Okay, so to ease your understanding, now I have here, okay, look at what happened on the left side of the picture. Okay, it is a very fast transmission of impulse. You just look at what happened to the inside and outside of the membrane changes. When one region is undergoing depolarization, the depolarization is spreading to the next region. So the previous region will then repolarize. So the color that you can see is actually showing you the movement of impulse, right? Where impulse is spreading in one direction. Okay, so the slow-mo video dekat bawah ni. Look at the animation down here, right? You can see the movement of ion. So when one region is depolarizing, it will cause the other region to depolarize. So you can see impulse is moving this way. Okay, right? So the previous region will undergo repolarization. Okay. Okay, next. Action potential cannot travel backward towards the cell body. So as you can see, impulse is transmitted from the dendrite of the cell body towards the axon and going to the axon terminal. And from there, it will be synapsed to another neuron. Okay, so impulse will be transmitted from here in one direction. So action potential cannot travel backward. Why? Because you can see from the animation, the previous region is undergoing repolarization. So remember what happened during repolarization? All sodium ion channel will be inactivated, right? So it blocks the flow of sodium ion through the channel. Okay, that is why impulse only travel in one direction. Because the previous region is undergo repolarization, sodium ion channel being inactivated, or we call as inactivation loop, block sodium ion flow through the open channel, right? Okay. All right. So finish with the continuous conduction for impulse transmission along unmyelinated axon or unmyelinated neuron. So now let's go and look at cell tertiary conduction. Okay, cell tertiary conduction is impulse transmission within myelinated neuron. Within myelinated neuron. Okay, right. So what happened is, let's say if we tend to draw, I can draw here. Okay, let's say this is our neuron and it has myelin sheath. Okay, so impulse is transmitted in this direction. All right, so no action potential happen or produced at the myelinated area. So meaning that at this area, there will be no action potential. No action potential. Why? Because part of the axon, right, that is covered with myelin sheath block, what I call it, act as insulator that block movement of ion. So this myelin sheath is actually blocked. movement of ions. Okay, so the part of axon that is not covered with myelin sheath is called as nodes of Ranvier. Okay, this part, right? This part that is not covered by myelin sheath we call as nodes of Ranvier. Okay, Ranvier. Okay, Ranvier, not Ranveer. To Ranveer Singh. No, this is nodes of Ranvier. Okay, so part of axon that is not covered by myelin sheath is known as nodes of Ranvier, and the nodes of Ranvier is concentrated with voltage gated ion channel. So the ion channel are all here at the nodes of Ranvier. So in other words, ions can only flow in between the nodes of Ranvier sahaja. Movement of ion only occur at the nodes of Ranvier. Okay. All right. So the uncovered area, right, uncovered part of the axon is in contact with the extracellular fluid of the membrane at the nodes of Ranvier, which allow movement of ion to happen at the nodes of Ranvier, but not within the insulated area. Okay. Okay. So myelinated axon is axon that covered with myelin sheath. The function of myelin sheath is as electrical insulator, right? Which it blocks movement of ion across the membrane. The myelin sheath is produced by the Schwann cell of the peripheral nervous system and also oligodendrocyte in the central nervous system. So these are all cells that responsible to produce the myelin sheath. Okay, so myelin sheath act as insulator, electrical insulator. So it blocks movement of ion. Okay, right. So what happened during cell tertiary conduction? Okay, ion movement across membrane only occur at the nodes of Ranvier. So remember, ion movement only occur at the nodes of Ranvier because that is the uncovered part of the axon. So the uncovered part of the axon is in contact with the extracellular fluid, right, which allow movement of ions. So depolarization occurs at the nodes of Ranvier, only at the nodes of Ranvier. So what happened is the depolarization spread along interior. Depolarization of one nodes of Ranvier spread along the interior of the axon to the next node of Ranvier and reinitiating voltage ion channel at the next node of Ranvier to depolarize. Okay, what does it mean? Okay, that is why action potential is appear to jump from one nodes of Ranvier to another nodes of Ranvier. Kita nampak seolah, bukan nampak, we can assume seolah-olah the action potential is jumping from one nodes of Ranvier to another nodes of Ranvier, but it jump interiorly. Okay, all right, let me show you this one. Okay, so this is the cell tertiary conduction. This is the nodes of Ranvier. You can see this region is undergoing depolarization. And this is another nodes of Ranvier here, right? So the depolarization of one nodes of Ranvier spread along interior. You can see spread along interior to the next node of Ranvier. So seolah-olah macam you just imagine that the depolarization is sort of like flowing in a vacuum area, right? Very fast transmission. So from one node, it can jump to another node of Ranvier, right? And cause the next nodes of Ranvier to depolarize. All right? Okay, and it will continues. So if I were to ask you, okay, which one is faster? Cell tertiary conduction or continuous conduction for the unmyelinated neuron? Which one is faster? Transmission of impulse. Yes, cell tertiary conduction, because you can see that what depolarization of one node of Ranvier spread thus to another node of Ranvier. Laju. For continuous conduction, the depolarization must be spread to the neighboring region. This depolarization, next one is depolarization, repolarization, depolarization, repolarization, depolarization, repolarization. So a little bit slow. Okay, so cell tertiary conduction is faster. Transmission of impulse is faster compared to continuous conduction because the depolarization spread along the interior of the nodes of spread along interior of the axon from one node of Ranvier to another node of Ranvier, and that is why the action potential is appear to be jump from one node of Ranvier to another node of Ranvier. Okay, soalan mesti tanya, why the transmission of cell tertiary conduction is faster? That is the answer. Okay, right. All right, so factors that affect the speed of action potential conduction. First, diameter of axon. Okay, the larger the diameter, the faster the transmission of impulse. So let's say we compare. This is axon A with this diameter, and this is axon B with this diameter. Right? So this is diameter. It is larger, right? So larger diameter of the axon can speed up transmission of impulse. Why? Because the resistance for the electrical current to flow will be lower. So resistance to flow of electrical current is inversely proportional to the cross-sectional area of the conductor. So in other words, the higher the diameter, the lower the resistance. So speed of impulse transmission is faster. Okay, that is the first factor that influencing the transmission of impulse. Okay. Second factor is type of axon. Okay, myelinated axon will transmit impulse more faster. Why? Because the action potential is appear to be jump from one node of Ranvier to another node of Ranvier. Okay, myelinated axon conduct impulse more rapidly than the unmyelinated axon. So it causes the depolarizing current to spread further along the axon. All right, so that is the second factor. Okay, so in other words, myelinated axon transmit impulse faster compared to the unmyelinated